Bismillahirrahmanirrahim. Assalamu alaikum dear students. I am your teacher Simi Namir. This is my lecture number 3 for grade 7 geography. So today we are going to start a new chapter, chapter number 2, Earth Alive. We all know that Earth is the only planet that has life. It has everything that makes a life possible to survive. But do you know, students, that there is some changes happening inside the earth? That's why we call the earth that earth is alive. And there are some changes, some waves of energy that travel through the earth and are result of an earthquake, explosion, or a volcano that imparts low frequency acoustic energy. So take out your books, page number 7. The first topic you have is Earth's internal structure. And I think we are done with this topic in a great detail in the previous chapter. Let me tell you again that Earth's internal structure will give us a greater understanding of planet tectonics. So Earth's internal structure is made up of three zones: the core, the mantle, and the crust. The core is the innermost layer. Scientists believe that it is made up mainly of iron and nickel. The core is further divided into inner and outer core. The inner core is made up of entirely of iron, and the outer core is an alloy, the nickel and iron alloy. Then second layer is mantle. Mantle lies between the core and the crust. Scientists also believe that it is made up of rocks. It is mainly molten, and the temperature in the mantle are about 800 degrees Celsius to 1600 degrees Celsius. The crust is the outermost layer. It is made up of a very thin layer of rock, and the earth is rigid and is broken into pieces. Sorry, the crust is rigid and is broken into pieces called the crustal plates. And these plates are constantly moving. There are two types of plates, the oceanic plates and the continental plates. The thickness of both plates are different from each other. The oceanic plates are thin and the continental plates are thick. Inside the mantle, the convection currents are formed due to the heat coming from the core. That's why the crustal plates of crust layer are constantly moving. The convection currents are helping these plates to move. The second topic of the chapter is plate tectonics and plate movements. I think this topic will give us a better understanding about the changes happening inside the Earth and the Earth's movement. Plate tectonics is the study of the changes that are taking place in the Earth's crust and the internal geological forces that bring about these changes. Plate tectonics is the theory that Earth's outer shell is divided into several plates that glide over the mantle. The rocky inner layer above the core, that is mantle, the plates acts like a hard and rigid shell compared to Earth's mantle. The word tectonics comes from Greek word tekton, which means a builder. It is a theory that describes how the Earth's crust is made up of plates and how these plates move across the Earth's surface. Due to these geological forces, the Earth's crust is constantly being destroyed and created at the same time. So on page number 7, figure 2.2, the figure will give you better understanding about that the Earth's crust is made up of several major and minor plates. The crustal plates and the top part of the mantle makes up the lithosphere. The lithosphere, the word is derived from the word lithos, meaning the rocky stone. It is primarily the rocky and stony part covering the whole Earth's surface, and the exact location is the crustal plates and the top layer of the mantle. The crustal plates and the top layer of mantle makes up lithosphere. The plate boundary is another important term that is used throughout this chapter. Let me tell you what actually the plate boundary is. Plate boundaries are the edges where two plates meet. Most geologic activities, including volcanoes, earthquakes, and mountain building, take, take place at plate boundaries. In simple words, the place where two crustal plates meet is called the crustal plate. In the book, on page number 7, in figure 2.2, you can see a small block given in blue color which gives you the different types of plate boundaries. Sorry. Different types of symbols are used to indicate the different types of plate boundaries. Here you can see the convergent boundary, the divergent plate boundary, and the transform plate boundary. Here in this slide, I have given these three figures to show the difference between the three types of plate boundaries. In a divergent boundary, it occurs when two tectonic plates move away from each other. So the arrows given here, you can see that they are moving apart from each other, they are moving away from each other. Along these boundaries, earthquakes are common and magma, molten rock, rises from the Earth's mantle to the surface, solidifying to create new oceanic crust. But in figure B, you can see this is the subduction zone. The divergent zone was the spreading zone because they were moving apart from each other, so they are actually the land is spreading. But in subduction zone, you can see when two plates come together, you can see from the arrows, they are coming together. It is known as the convergent boundary, and they are colliding. The impact of the colliding plates can cause the edges of one or both plates to buckle up into a mountain ranges, or one of the plates may bend down into a deep seafloor trench. Here you can see a chain of volcanoes often forms parallel to convergent plates boundaries, and powerful earthquakes are common along these boundaries. So the sign here given, the black stars actually are used for the earthquake zone. At convergent plate boundaries, oceanic crust is often forced down into the mantle where it begins to melt. Magma rises into and through the other plate, solidifying into granite, the rock that makes up the continents. Thus, at convergent boundaries, continental crust is created and oceanic crust is destroyed. In the third one, which is transform plate boundary, they are not moving towards each other, they are not moving apart from each other, they are just sliding by. They are just sliding by each other. So you can see from the arrows, the movement shows from the arrows that they are just sliding past each other, forms a transform plate boundary. The natural or human-made structures that crosses a transform boundary are offset, split into pieces and carried in opposite directions. They are creating a linear fault valley or undersea canyon. Earthquakes are common along these faults. In contrast to convergent and divergent boundaries, crust is cracked and broken at transform margins, but is not created or destroyed. On page number 8, you can see the topic the types of crustal plates. We learned in the previous chapter that the Earth's crust is broken into pieces, and these pieces are actually called the crustal plates. But you know, dear students, that the crustal plates are of two types. I think I have already told you in the previous chapter that these plates are of continental plates and oceanic plates. The continental plates are made up of continents and parts of oceans. So they are actually made up of continents, the whole continents, and only parts of oceans. For example, the Eurasian plate. The continental plates are comparatively less dense and lighter than oceanic plates because they are made up of lighter elements. They are also thicker than oceanic plates as they are less dense than oceanic plates. They rest higher on the mantle. The oceanic plates are the land area beneath the sea. This is thin, dense, sinks under the continental crust and young. They are made up of rocks that are not too old, but the continental plates are made up of older rocks. The example of an oceanic plate is the Pacific plate, thinner but denser than continental plates. Oceanic plates are made up of heavier elements with a relative density of usually more than 3. So, as they are denser, they usually rest lower on the mantle. So, that was all about the plate tectonics. On page number 9, you can see plate tectonics in Pakistan. So let me tell you about the location first. The geographic location of Pakistan lies between 60 degrees east to 78 degrees east and 24 degrees north to 37 degrees north. They are actually telling you about the longitudes and the latitudes of Pakistan. That is the location of Pakistan, and it has a high density of active faults and is seismically one of the most active area of the Asia. Just because of the location of Pakistan, you can see in figure 2.3 on your book that Pakistan lies at the boundary of two crustal plates. Here, the Indo-Australian plate and the Eurasian plate. The Indo-Australian plate because the area comes here, the Indian area, so this is also called the Indian plate, or you can say the Indo-Australian plate. And the upper area is the Eurasian plate, which is actually the combination of the Europe and Asian area. That's why the plate is called the Eurasian plate. Both the Indo-Australian and the Eurasian plates are the continental plate. The boundary between the plates cuts across the center of Pakistan in a northeast and northwest direction. The destructive plate boundary where the Indo-Australian plate collides into the Eurasian plate. Eurasian plates extends from Makran in Balochistan to the Hazara in Kashmir. Sindh, Punjab and Kashmir are located on the margin of the Indo-Australian plates, whereas Balochistan and Khyber Pakhtunkhwa are located on the margin of the Eurasian plate. In the figure, you can see the arrows that are towards each other. So it means that the plates are moving towards each other, so that must be a convergent plate boundary. And you know that these plate boundaries are making mountain ranges. When they are colliding, they are making mountain ranges. But tectonically, it is located in a region of intersection of three plates. That's why we can say that three plates are intersection: the Indian plate, the Eurasian plate, and the Arabian Sea plate. You can see in the figure that the Arabian Sea plate is also there. Actually, the area of Pakistan, we can say the land of Pakistan, is where only two plates are colliding. But at the seabed, you can see the Arabian Sea plate. In the north, there is a convergent plate boundary between Eurasian and Indian plate, resulting into a great Himalaya. I have told you that when the two plates are convergent plate, they are colliding and they are forming a mountain range. Here we have the Great Himalayan Range. But in the west, the intersection between these two plates became transformed in nature. So they are just sliding apart, sorry, sliding with each other. As both the Indo-Australian and the Eurasian plates are of the same density, when they collide, folding occurs. Means the folding mountains are formed here. The figure of your book, the 2.4, figure 2.4 shows the processing of folding that led to the formation of the Himalayan fold mountain range. As the Indo-Australian and the Eurasian plates are still moving towards each other, the Himalayas continues to increase in height every year. This increase is really minor, but still it gives us the impact of Earth alive. Also, as these two plates continue to move towards each other, so do earthquakes continue to occur in Pakistan and the neighboring countries. In fact, one of the Pakistan's deadliest earthquakes, 7.6 on the Richter scale, occurred in 2005 in Pakistan administered Kashmir. The earthquake was caused by several upthrusts and left about 79,000 dead. There is also a subduction zone in Pakistan which is called the Makran subduction zone. Arabian plate which is subducting beneath the Makran margin dipped gently northwards. Pakistani Makran is bounded between two strike slip fault system. To the west, the Ney fault of Harry Dredd zone, and to the east, the Chaman transform zone.
सबसे पहले देखते हैं टेक्टोनिक प्लेट्स जो हैं वो क्या हैं। जो ज़मीन है, ये जो ज़मीन है इसकी जो तीन परतें हैं जिनकी हम लास्ट लेक्चर के अंदर बात कर चुके हैं कि सबसे अंदर वाली कोर है, बाहर वाली मेंटल है और सबसे बाहर वाली क्रस्ट है। ठीक है, तो ये जो क्रस्ट है जिसकी जो मोटाई हमने देखी थी कि 20 से 70 किलोमीटर तक है, तो ये जो 20 से 70 किलोमीटर की मोटाई वाली तय है जिसे क्रस्ट कहते हैं, इसके अंदर बहुत से फॉल्ट्स हैं, यानी बहुत सी दरारें हैं। मेरी बात को समझ रहे हैं ना? ये जो क्रस्ट है इसके अंदर बहुत बड़े बड़े फॉल्ट्स हैं। तो वो जो फॉल्ट्स या जो दरारें हैं वो क्या बनाती हैं? उन्होंने प्लेट्स बना दी अर्थ के अंदर। ठीक हो गया, अर्थ के अंदर क्या कर दिया? प्लेट्स बना दी, और वो प्लेट्स हर टाइम पे एक दूसरे से टकरा रही हैं, और यही टेक्टोनिक मूवमेंट है, और इन्हीं को टेक्टोनिक प्लेट्स कहा जाता है। ठीक हो गया, तो अभी जो है 7 बड़ी प्लेट्स दुनिया के अंदर मौजूद हैं और 21 छोटी प्लेट्स मौजूद हैं। अब ये जो 7 बड़ी प्लेट्स हैं, टेक्टोनिक प्लेट्स हैं, इन्हीं को 7 कॉन्टिनेंट्स भी कहा जाता है। कि जो 7 बरआज़म जहाँ जहाँ आइडेंटिफाई किए गए, ठीक है ना, तो ये जो बरआज़म हैं या कॉन्टिनेंट्स हैं, ये एक्चुअली में क्या है? ये 7 प्लेट्स हैं, और ये हर टाइम पे टेक्टोनिक मूवमेंट कर रही हैं, और 21 छोटी प्लेट्स हैं। अब इसी तरह से जो पेंजिया है वो क्या है कि जो जियोलॉजिस्ट हैं उनका ये मानना है कि जो अर्थ है जो अभी इसकी फॉर्म है, आज से कोई 20 करोड़ साल पहले जो है ये अर्थ जो आज 7 प्लेटों पर मुश्तमिल है, 7 प्लेट्स हैं, ये कभी एक प्लेट हुआ करती थी। ठीक है, ये सारे के सारे 7 कॉन्टिनेंट्स एक प्लेट होते थे, और ये सारे के सारे ज़मीन का एक ही टुकड़ा था जिसको पेंजिया कहा जाता था। ठीक हो गया, कि ये जो अर्थ जो 7 प्लेटों पर आज मुश्तमिल है, 7 प्लेट्स हैं, किसी ज़माने में आज से 20 करोड़ साल पहले जो है सिर्फ एक प्लेट थी जिसे पेंजिया कहा जाता था। ये है पेंजिया। तो अब ये क्या है, उसके बाद क्या हुआ कि करोड़ों साल का क्योंकि ये प्रोसेस है, तो इस प्रोसेस के दौरान ये टेक्टोनिक मूवमेंट्स होती रही, ज़मीन का जो क्रस्ट है उसके अंदर फॉल्ट्स पैदा।
So let me give you an assignment here. It's a short question. What are plate tectonics? And the answer is plate tectonics is a study of the changes that are taking place in the Earth's crust and the internal geological forces that brings about these changes. The word tectonics comes from the Greek word tekton, which means a builder. It is a theory that describes how the Earth's crust is made up of plates and how these plates move across the Earth's surface. You can find this answer in on page number 7. Let me tell you again. Plate tectonics is the study of the changes that are taking place in the Earth's surface, Earth's crust, and the internal geological forces that brings about these changes. The word tectonics comes from the Greek word tecton, Tekton, tecton, which means a builder. It is a theory that describes how the Earth's crust is made up of plates and how these plates move across the Earth's surface. The second question is, why do crustal plates move? And the answer is that the crustal plates are constantly moving because of the convection currents, which occurs in the semi-molten mantle. These convection currents are created by the heat from within the Earth, much of which is generated by radioactive decay in the core. Let me tell you again, the crustal plates are constantly moving because of the convection currents, which occur in the semi-molten mantle. These convection currents are created by heat from within the Earth, much of which is generated by radioactive decay in the core. So that is your assignment. You have to do both questions. These are short questions. The first question is what is tectonic plate tectonic, and the second question is why do crustal plate move? Do neat work. Do both the question in your notebook. Make a margin line. Write your date, Google Classroom work, and please maintain your index along with proper date. Thank you. Thank you so much guys for watching this video. We'll meet up again inshallah in the next video with a new topic. Bye.